When you want to pattern or hatch around an enclosed area, MicroStation must be able to identify both the outer boundary and the hole boundary. Essentially, this means that both boundaries must be closed elements of some type. Holes can be regular closed shapes or connected elements for some tools, while other tools require the hole to be a whole element, as opposed to a standard solid element. Whole elements can be set when the element is first placed or edited to a whole element later. If you know that you'll be patterning around elements later in the design process, you can draw the whole elements as whole elements. And the whole option is available under the Area mode in the Tool Settings window for any closed element tool, including SmartLine. Now, as you would expect, MicroStation has a whole raft of options and requirements for patterning around holes. And we're going to take a look at the most obvious ones in this video. But to help things along, I've listed the various methods and requirements in a file called patterningaroundholes.pdf located in your Working Files folder. Now, the first method we'll have a look at is the flood method. And on the screen you can see I have several elements in place. At the moment, the outer boundary is a block, the circle is obviously a circle, and the inner boundary is also a block. And I have a text string on the screen as well. Now, these are all closed elements in their own right, but they don't have to be for this method. I have the Hatch Area tool running at the moment. I have my settings set. I have my attributes set for the actual hatch itself. And we can begin by selecting the flood method. Now, here we have to choose which particular style of hatching we need in relation to holes. And because I have separated holes here, I will click on Locate Interior Shapes. My text option, Locate Interior Text, is also on because I have text. I want the hatching to hatch around the text, not through it. In this case, I've got Dynamic Area Locate on, but that's not particularly necessary. So, into the shape, data point anywhere inside the enclosing area, data point to accept, and my hatch is drawn. Now note particularly that the hatching does not extend across the text, which is exactly what I want. Now, as I said, with this method, it doesn't particularly matter whether the elements to be hatched or the boundary are closed elements. I could, for example, very quickly draw connected lines, and inside that, draw connected lines, and hatch that. Same settings. Data point, and the hatching is done perfectly well. So the flood method is extremely useful and one which you're liable to use the most. Let's try a different method. I'm going to undo everything to this point. Back to the tool. Let's try the difference method now, which is a Boolean operation. We'll use the same elements on the screen. Now, in this case, the difference method requires you to both select the outer boundary and the inner holes as well. So let's see how that goes. So identify the element, which will be the bounding element. Then identify additional elements. Now, in this case, we need to identify that. And to identify this, I must hold down the Control key to add that to the selection set. Note that I cannot select the text. Data point, and the hatch is done. Note, however, that the hatch goes through the text, which may or may not be what you want. Let me undo that and use that method again. I wanted to see what the difference is if I only select one of the closed shapes inside the boundary. So I select the first one, I'll select the small closed shape and nothing else. Data point. Hatching goes around this one because it was selected, but hatching goes through the circle because it was not selected. This way, at least you can specify exactly where the hatch should be or shouldn't be. Now, so far, we've used just the flood method. But what if you wanted to use the element method? Let's see what happens here. Notice that with the element method, we must choose whether to search for holes or not. The default is no. I switch mine to find holes on the element level, meaning that any hole that's on the same level as the boundary will be found. And let's see what happens this time. So now I must identify the element, which is the outer boundary, and data point for the pattern intersection point, anywhere will do. But see what happens. the holes are not found. And that's because with the element method, the holes must be whole elements. So there are a couple of ways of doing this. Let me show you two. I'm going to delete the hole and the rectangle. And let's place the circle again. Change that back to 1, change that back to 0. Start the circle tool. Area, default is solid, but I want to place a whole element. So I change the area to whole. Now I can place my circle, and that's a whole element. Change that back to solid. Let's place that rectangle again. That is not a whole element. Change my parameters for the active attributes. And let's try hatching again. Element method, search for holes, select the boundary, data point for the pattern, and the hatch has found the circle, which is a whole element, but not the rectangle block, which is not a whole element. Undo that. Let's change this block into a whole element. Tool I need is change to active area. Default is solid. Change it to a whole. Select the rectangle, and let's hatch again. Now, being a whole element, the hatching goes around the rectangular block, but it still goes through the text, and there's no way around that with this particular method. Now, if you had whole elements on different levels, you could switch to view levels, which means that it will find holes on all levels visible in this view. Not the whole drawing, just those in this view. Now, before we leave this particular tool, one thing you must do is go to any of the closed shaped tools and change the area back to solid. What you don't want to do is carry on drawing and creating whole elements where they're not needed. That simply complicates things. Now, one last method to use, and that's the element and group holes method. And I'm going to undo right back to where I was with simple elements, not whole elements. So these are solid elements. Double check. Circle, and it's a primary class. That's important. You can get rid of that. Now, the group holes method requires us to group both the outer boundary and the inner holes into one group called an orphan cell. Now, that simply means that the cell is not in a cell library. It's simply in place in this drawing on its own. So in other words, the poor little cell is orphaned from the main cell areas. Now, to do that, we need to go to the Group Hole tool, Group Holes, watch the prompts, identify the solid element, that's that one, identify the whole elements, there's this one, and I'm going to hold down the Control key and select that one. We cannot select the text again, so I data point to accept that, and right-click. Now, if I select the enclosing element, you'll see that they are all one cell. I'm going to undo that, so we know the procedure has worked. And now we can hatch. We use element method again. We can turn that off. And we simply select the element and data point for the hatch, and it pops into place immediately. So again, this method is useful if you absolutely know that any closed shapes that you're drawing will be patterned around. It guarantees that since they're holes, they would not be patterned over. Now, you notice I haven't mentioned associative pattern up till now, and use of that depends on the method that you've selected to hatch or pattern with. I'm not going to talk about that. I'm going to let you experiment on your own with this. You have the information in that file on your working files folder. It'd be very helpful if you went through it yourself, just to reinforce what we've done in this video, and experiment with the associative pattern. Hatching and patterning is a very common thing to do in a drawing, and you really need to know how to do it as well as possible.